We're going to go ahead and wrap up this lesson with a couple examples that are just some weird situations, but I just want to remind you that we don't assume anything based on the work. We just do these steps over and over again, where we do the work above the number line, then we go back to the original problem and say blue and red or blue or red, and figure out where it's shaded on the number line, then get the interval notation. Just keep following those steps over and over. So we're going to say this first one is blue. We're going to call the second one red, and we're going to do a number line. We're going to have a 3. We're going to have a 5. So we broke the number line up into 3 chunks. We're going to do each of these graphs above the number line. So the first one was greater than 5, so we're not including 5. We shade everything to the right. For the red one, we don't include 3. We shade everything to the left. Now what's really, really important is this word and. If we look at the leftmost chunk, do I have blue and red? No, I don't. So I'm not going to shade that. In the middle chunk, do I have blue and red? No, I don't. So I'm not going to shade it. In the rightmost chunk, do I have blue and red? No, so I'm not going to shade it. So what did I shade? Nothing. I have a blank number line. That means my final answer is no solution. This is also why we do the blue and the red above the number line. We don't want to put stuff on the number line and all of a sudden say, ooh, I got stuff shaded. The answer is supposed to be no solution. Now, if we look back to the original problem, common sense tells us there's no solution. The original problem is saying, I'm looking for a number that's both bigger than 5 and smaller than 3 at the same time. There's no such number. And if we look visually at what's going on the number line, we're looking for where those two things overlap at, and they don't overlap. So I do want to point out that this looks really similar as far as the work, as far as above the number line, to our example 11. Example 11 had the blue going in one direction, the red going in another direction, and we didn't have no solution. But that's because we had an or. The word that we have makes all the difference in the world. Just like 1 plus 1 is not the same thing as 1 minus 1. You get 2 different answers. You get 2 different answers if you have an and versus an or. So it's really important just to go through your steps and not try to say, when my lines are pointed opposite directions, the answer has a union or anything crazy like that. Just do the problem. Do the work, figure out what gets shaded, and then get the interval notation. So let's go ahead and look at one more. Now we'll again go through our first steps of saying this guy is blue, this guy is red. We got ourselves a number line. The important points are 3 and 5. With the blue one, we do not include the 5. We shade stuff to the left. With the red one, we do not include 3. We shade stuff to the right. But it's again important that we have the word or here. You'll get a different answer if it's an or versus an and. Because this is or, we start off with the left chunk and say, do I have blue or red there? And the answer is yes. So we shade. Then we look at the middle. Do I have blue or red there? Yes, and so we shade. Then we look at the rightmost chunk. Do I have blue or red there? Yes. So if you look at what I've shaded the whole number line. The leftmost endpoint that I shaded is negative infinity. The rightmost endpoint that I shaded is positive infinity. I shaded everything from negative infinity to positive infinity. That's everything. So as you can see, we can get intervals that have 2 endpoints, from 2 to 5. We can have an interval that has negative infinity on one side, a number on the other. We can have two intervals. We can have no solution. We can have negative infinity to infinity. We can have a lot of different possible answers. Don't try to generalize. Don't try to come up with rules that my answer is going to look like this in these situations. Just go through the steps. Every time, just go through the steps. Get the inequality so that it's x and x. Give them colors. Put those inequalities above the number line. And then just go back to blue and red, or blue or red, depending on what the original problem called for. Get your answer on the number line. Take that answer from the number line and put it in interval notation. That's what we're going to do every time.